say we want to know what the equivalent circuit would be if we were to attach a resistor across these two nodes. So we have 5 resistors, we have a current source, we have a voltage source. We're going to use a source transformation. We're going to combine some of the resistors, and let's assign each of these a value of R. We will assign our current source a value of I, and our voltage source simply a value of V. So the first step, we're going to do a transformation right here, where we can take that and we can draw an equivalent system with a resistor and a current source in parallel. So let's redraw that right now. Our resistor will still have a value R. Our current source will have a value V over R. Okay, next we can take these two resistors that are in parallel and combine them. And we can also take these two resistors that are in parallel and combine them. So we'll have a blue one and a purple one right there. So let's redraw. And these equivalent resistances are going to be R over 2 for each of them. Okay, now we're going to combine our current sources, which are both flowing into this node and flowing out of this node. So we can just add them together, and we'll have an equivalent current source over here. So let's redraw that. This is going to be I plus V over R. And here we have it. And remember, we still have our resistor there. Okay, so now we have to combine our circuit in a way that we will know we'll have our current source, and we'll also have our equivalent resistance as seen from the node that we're hooking it up to. So what that's going to be is, we'll do this in orange, from this node starting at the positive terminal and going to the negative terminal, we have 2 ways of going about that. So what that's effectively going to be, our equivalent resistance is going to be our R over 2, and that's going to be in parallel with our red resistor and our purple resistor added together. So find this value. So really quick, we'll do the math here, where we have inside parentheses, that's 3 halves R. So we have R over 2 multiplied by 3R over 2 divided by R over 2 plus 3R over 2. This will yield us 3R squared over 4 divided by 2R. R's cancel. We end up with 3/8 R. So our equivalent circuit, we can redraw this now. It's going to have one resistor between these terminals, and it's going to be 3/8 R. And we have that in parallel with our current source of I plus V over R, and there's our equivalent circuit.